Let's now look at a problem in which they set up a process using our variation ideas, and they want us to actually go through and solve an application problem with the variation. So this problem starts out by saying, for a fixed rate, the distance d that a car can travel varies directly with the time traveled at that rate. So within this first sentence, we have a variation set up, a direct variation set up between the distance traveled and the time traveled at that rate. Now continuing on, it says if the car can travel at 130 miles in 2 hours, how far can it travel in 5 hours? Now the whole kind of outline of how we're going to approach this problem is we're going to take our sentence that describes the variation going on here and write our variation equation like we did in the earlier segments. Then we'll use whatever we can find that's a full set of information of the variables, and the only unknown at that point is our constant of variation, to allow us to find the value for the constant of variation in that problem. That will let us get a specific equation for this particular situation in which we can use to finally use in the last steps to find our answer. So let's start at the beginning where it talks about the variation. The distance d that a car can travel varies. So d is the variable that's before the variation is described. So d will be on a side by itself, and then we'll put the equal sign. And it varies directly. So remember, with the directly, we multiply our constant of variation by our variable. So we'll put down our k for our constant of variation that we have to remember. It's embedded in the idea of the variation process. And it varies directly. We'll multiply by the time traveled at that rate. And they didn't tell me a variable to use for time, but it makes sense that we possibly would use a variable that would represent the idea. And since time starts with the letter t, we'll just use t for time. So d is equal to k times t is our variation equation. Now we're going to set a full set of information in order to solve for our constant of variation. It says if the car can travel 130 miles, well 130 miles is a distance, so we'll put that in the distance side. In 2 hours, 2 hours is a time. So I'll go ahead and put in our 2 hours for our time t. And notice the constant of proportionality or variation stays k. We don't have a value for that. But it's the only variable in here. So I can go ahead and solve for k by dividing both sides by 2. And that will give me a pair of common factor of 2's to remove on the right-hand side. I get the k is equal to, and 130 divided by 2 is 65. So my k is equal to 65. What that does is it allows me to take this direct variation equation and take out the k and put in 65 that's true for this specific situation. So my equation now specific to the whole setup is that the distance is equal to 65 times t. And now I can go ahead and finish off with the rest of the process of the question that's asked. So then now it says, well, how far, so what's your distance that the car can travel in 5 hours? And 5 hours is time. So we're going to have our distance is equal to 65 times, take out the t and put in 5. And so here we have our distance is equal to 65 times 5 is 325. So the car can travel 325 miles in 5 hours if it's traveling at a constant rate of 65 miles per hour.